Since the 1950s, NASA has studied how to land spacecraft on planetary bodies, as the entry, descent, and landing phase can be the greatest challenge for destinations with an atmosphere. The first atmospheric entry test used ballistic missiles with long, narrow nose cones, but their high speeds and low drag caused overheating and melting of the rocket's surface. So, NASA researchers tested blunt nose re-entry vehicles that reduced heat transfer by increasing drag compared to traditional shapes. While blunt body designs work well, engineers and scientists at NASA's Langley Research Center developed a more versatile concept: a hypersonic inflatable aerodynamic decelerator, or HIAD. The inflatable spacecraft technology is made up of strong yet flexible fabric, designed to maintain its shape and withstand the heat and force of rushing through an atmosphere, offering reduced mass and increased size, both crucial in space travel. During launch, the uninflated stacked rings are packed inside a bag, and right before the spacecraft enters the atmosphere, a compressed gas system increases the volume of the inflatable structure. Entry, descent, and landing of any spacecraft to a destination with an atmosphere creates some unique but common problems. First, the vehicle must be slowed down enough to safely land. In order to use some of the atmosphere to slow the vehicle, engineers have to increase the aerodynamic drag on the vehicle. Drag is the aerodynamic force that opposes an aircraft's motion through the air. To land twice the mass, the vehicle must have twice the drag area. By increasing the diameter of the vehicle, engineers are able to deploy larger vehicles. But the second problem, heat, requires that vehicles have a thermal protection system. As a vehicle traverses the atmosphere, a large amount of friction is created. The impact of air molecules on one another transfers a great deal of heat to the surface of the entry vehicle, in a process known as aerodynamic heating. Unlike traditional aeroshells, HIAD is much larger in diameter, allowing the heat to spread over a larger surface area. In a HIAD, several materials are combined together in layers to insulate the larger inflatable heat shield, providing effective heat resistance and making HIAD a unique solution for the problems of entry, descent, and landing. Inflatable technology could give NASA more options for future planetary missions, as it can be used on any planet or object in space that has an atmosphere. This new tech will advance space exploration, both robotic and human, allowing new scientific discoveries, changing the way we explore new worlds. By measuring atmospheric heating with balloons, students will be able to discover the difference between qualitative and quantitative data, collect, organize, and interpret data, and use their data to explain transfer of heat energy.